Notes 4.3 Inverse property of logarithms and exponents. So now that we know how to rewrite in exponential and log form, we're going to use that to evaluate these logs and these exponents. So 10 to the log base 10 of 3. We're going to figure that out. So equals something. So now you have to figure out, is this in exponential form or logarithm form? Now it doesn't say log here, so it's most likely in exponential form. So we want to put this in log form, so log, log, circle the base, right next to that g right there, that's our base. What's on the other side? Question mark, equals the exponent, which is this whole thing right here. So log base 10 of 3. Now that we see that they're equal, if these are equal, the question mark has to equal 3, because the logs will cross out. Question mark equals 3. So 10 to the log base 10 of 3 is equal to 3. Example 2, log base 10 of 10 to 3.28. And we're going to figure out what this is equal to. So I'll put it equal to question mark. Now this is in log form because it started out with a log. So we're going to put this in exponential form. We're going to circle our base, which is 10. You didn't circle both, just circle the base next to the g. So go and write 10. And then the other side of the equal sign is a question mark. So question mark equals, on the other side of question mark is 10 to 3.28. Now, one-on-one base, property of exponents. So the 10's crossed out, question mark has to equal 3.28. Question number 3, log base 5 of 5 to 3x equal to something. Now it's in log form, so I'm going to put it in exponential form. 5 to the question mark equal to 5 to 3x. The 5's cancel out. One-to-one property of exponents. Question mark has to equal 3x. Example 4, log base 4 of 64 is equal to something. So I'm going to put this in exponential. 4 to the what is equal to 64. Now 4 times 4, how many times will give you 64? So question mark has to be 3. Example 5. 5 to the log base 5 of 8 minus log base 4 of 64. Now this one's kind of tricky because there's two parts to it, so I'm going to separate it. I'm going to do this part first, then I'm going to do this part. So I'm going to go 5 to the log base 5 of 8 is equal to something. We're going to figure that out. This is in exponential form, so I'm going to put this in log form. So log base 5 of question mark is equal to log base 5 of 8. It's a one-to-one property of log, so question mark has to equal 8 for them to be equal. So I know this part is equal to 8 minus, and I just did this, log base 4 is 64. It was example 4, so that is equal to 3. So 8 minus 3 is equal to 5, and that is our answer. And the last one, question 6, log base 6 of 36 to the 5x. And we're evaluating, so equals something. This is in log form. I'm going to go ahead and put it in exponential form. 6 to the question mark is equal to 36 to the 5x. Now I want to try to get them the same base. So the 36 turns into 6 squared. 6 is crossed out. Question mark is equal to 10x. Now that I know that, I'm going to go ahead and state the inverse property. The inverse property says if you have a log of a base of another base to an exponent of x, this will equal x. Now you can do vice versa. If you have a base and you have an exponent of a log of the same base, we'll call it y. This is equal to the letter y. Thank you for listening to Notes 4.3, Inverse property of logarithms and exponents.